In this video, we'll introduce how to use Novita AI platform to create and manage serverless services. First of all, after logging, we can see the console section on the main page, which serves as the entry for managing resources, and we'll focus on the usage of serverless services. Click Serverless to enter the product console. Here, Novita provides a variety of GPU cards to meet different computational and budgetary needs. You can select the appropriate card based on your actual requirements. Pay close attention to the billing options below. In this demo, we'll use a 4090 GPU card. Click Create Endpoint to create a serverless instance. Fill in the basic instance information. The endpoint name is randomly generated by the system. Next, configure the worker configuration. You can click the question mark for more specific instructions. A worker is an instance that offers model services externally, and you must create at least one. Set the maximum number of workers to 3 for this demonstration. The idle timeout determines the cooldown period for scaling, which we'll set to a shorter value for demonstration purposes. Each worker's max concurrency is set to 4. Leave the remaining options as default. The platform provides 2 types of scaling rules. Click to see the detailed explanations. For this demo, we'll use queue delay as the scaling metric and set it to 4. Next, configure the container image using a pre-prepared image. Since we're not using a private repository, authentication is not required. Set the port to 8000 by default, as the container will provide services using this parameter. Use pre-configured container startup parameters, including model details. Mount a pre-prepared storage for faster image loading later. Then configure the health check path using the health endpoint. After confirming all parameters are correctly filled in, click Deploy to create the instance. In the console, you'll see that the endpoint has been created. Refresh the instance list to check its status. The system will generate a corresponding endpoint URL, which can be viewed in the logs or the container viewer. If you need to modify the endpoint settings, click Edit to update and save the configurations. After refreshing, the worker instance has been successfully created and is running. Copy the endpoint URL and check the model information via a browser. If the browser returns the model's output, it indicates the model is functioning correctly. Next, use 2 pre-prepared curl commands to test the model's inference capabilities. Several adjustments are required here. Copy and paste the endpoint into the curl command. Specify the model name. Adjust the token's parameter. After invoking the API, you'll see a valid response. Modify the parameters for another curl command, and the inference is also successful. Now, use a pre-written script to simulate a client sending inference requests. The script requires 3 parameters: endpoint URL, model, and the number of concurrent requests to be sent. We'll perform a computationally intensive inference task, such as tell me a story. The script successfully returns results, and the logs display the processing details. Next, simulate a scenario with multiple concurrent users to trigger autoscaling. Run an additional script and check the console. You'll notice that a worker has been added to handle the increased load. Simulate 2 concurrent users accessing the service. After running the scripts, 2 new workers are triggered. The logs will show the workers' runtime details during scaling. Now all 3 workers are actively providing services. The logs from the scripts confirm that the returned outputs are lengthy and correct. Stop 2 client scripts and refresh the console to observe the changes in worker instances. The logs indicate that the remaining 2 workers are operating normally. Stop another client script and refresh the status. After refreshing, you'll notice that the number of workers has scaled down to 1. On the client side, the service continues to operate normally, with valid responses being returned. Here we finish a simple scaling and shrinking process.